Do you guys have any questions on the homework? I'll pull that up. Yeah, so it was some of the weather lessons, the dew point. I know Sam had a question in the group, or he was wondering about dew point. He's struggling maybe with it. Sam, did you get that sorted?
So yes and no. Yes, but I want to go over that lesson again one more time and really just feel like I'm very confident on it.
Okay.
Um, it's relatively straightforward, but when I was working out some of them, I would like miss a step and think, shoot, how do we get to that step? Or how do we get to the next step? So, um, yeah,
Yeah.
I agree. The weather charts are not easy as well.
What specifically about the weather charts?
Actually, like when it was four pictures together and like
Hmm.
what was going on with that? Because I had different information in each picture. Was it just like layered so like you could actually read it? Is that why it's like that?
The
The significant and wide area weather charts.
Yeah, where it's like 12-hour forecast, 24-hour forecasts, things like
Yeah.
that. Yeah.
And I
Um,
also had a really hard time reading the actual seeing the photos, like getting being able to actually read the print.
Yeah, I
oh,
did too.
were they like blurry?
I also just can't see.
Well,
No,
say,
I couldn't zoom in far enough on my computer. Like I was trying to increase it. Like I had to take pictures of it with my phone and then blow it up.
interesting. Um, do you remember which picture that was, or was it multiple pictures?
All of them, every single question that had the
Oh, like in the quiz?
yeah.
Okay.
I had one as well, Nick, that it was like referred to the figure and it was like figure 284. So I went to like go to the let me what's it called? The Airman Knowledge book that you gave us, and that
Hmm.
figure isn't in there.
Yeah, so I kind of didn't mention this in the VIP, but in the intro lessons and in the introduction we send people, we kind of have our own PDF where we added additional figures to that. And it's in your bonus downloads course, and it's also in the intro lessons of the step one course.
Oh, okay.
So there's a few kind of figures that we added to that. So that's where you'll find those.
Okay.
Yeah, sorry about that.
Oh, all good. I was just like trying to figure it out.
So is it like this figure? This one? Oops.
No, it was the one in the actual test
Okay.
when you hit take the test.
Yeah, let's see. And then Ivan said, can we do a few examples together? Sure. Oh, was it this one?
Yep.
Yeah.
Yeah, there's like four questions like that.
Okay. Is it like the words that
Well, I just like the four pictures together kind of confusing me. Like, is this over a timeline or is this at a single point in time?
okay, so the keys are yeah, so the keys are here, right? So you have 12-hour significant weather, low level. You have
Where
24-hour significant weather, low level, and then you
where are
have
you seeing that?
uh right here.
Like,
Can
like
can you
where?
see? Hold on, let me get like a pointer. Uh, can you see this little box?
No.
Can you guys see my screen? Like
You can
Yeah, I
zoom?
see
can
your
see it.
screen.
I
Yeah.
can see the box.
Oh, I can see your little pointer now. Okay.
Yeah. And so these boxes, these tell what they are. So you got um 12-hour significant weather. So it gives you a forecast 12 hours in advance. It's like expect these things 12 hours from now. This is 24 hours from now. And then what this is you can consider this like high level, and then you have low level. So this is like it says surface to 400 millibars of pressure. Um, just think of it, like surface to I don't know what altitude that would be, but just low level altitudes. Like for us, general aviation, we would want to, you know, look at these low level ones for like, commercial pilots and things like that. They'd look at these high level ones or both, but you get what I'm saying because we don't fly at super high levels. So that's the basis of these four different charts. There's a 12-hour, 24-hour for both low level and kind of medium to high level. Does that make sense?
Uh, yeah.
Doesn't sound like it.
But like,
What's your question?
I don't know my questions. I think I just need to go through the course one more time.
Okay, no worries. So let's see what this question says. What kind of precipitation can be expected in the 24-hour forecast in northeast Minnesota? So the confusing part of this, like this is how the FAA kind of does it. They don't exactly tell you which one, right, you want to look at. They kind of tell you two. So they tell you 24-hour, right? So it's going to be either of these two on the right. But if you can see on this like significant weather one, not this low level, there's different kinds of information here as well. You can see that in the bottom ones, which have these, they're not low level, they have more like um, details on the types of weather. So like precipitation and things like that. Where up here, you just have mostly thunderstorm, turbulence information, ceilings and visibilities, things like that. So, and we know that from these symbols here. So we're looking for northeast Minnesota. So that's going to be up here. We got this little triangle with a dawn on it. Triangles mean showers. So this would be like rain showers, right? And so rain showers there. Does that make sense? Yeah. Did may have
Yeah,
any?
the symbols are easy to
Okay.
remember. It was just like
This one again.
yeah, the times was what was just like I couldn't read it. I was having a hard time actually seeing the boxes on my
Okay.
screen.
Gotcha. Yeah, this one seems pretty clear on my computer. But if you do have the PDF, when you zoom in on the PDF, it'll maintain it's like a PDFs are like, I can't remember the word, they're vector oriented or whatever, vector graphics. So they'll maintain their clarity when you zoom in on them. So uh, it helps to have the PDF um up as well. I've been looking into the solution to like embed like a PDF for these, but it's really it makes the quizzes really cumbersome. So I haven't done that, but so you kind of have to on some of these charts when you zoom in, you kind of have to live with a little bit of granularity.
Nick, do you have a like something blocking when if I copied and pasted that question into Google, it said when I try to Google it, it says copying not allowed. Do you have some sort of like blocker or something?
Yeah.
Okay, okay, fair enough.
Yeah, I mean, you could take a picture of it and upload it to like, you know, ChatGPT or something, but like it's not stopping you from doing that. But yeah,
Yeah.
I had some people copy my course when I first made it, and so I just
Fair enough.
set that
Yeah.
out. Yeah.
Also, can you mute me? My mouse has just died and I'm unmuted and I can't do
Okay.
otherwise because it's broken. Thank you.
Yeah, sure thing.
Actually,
Um,
I got it. I got it. I got it.
okay. Let's see. Let's just go through a couple more of these. This one gets a little, I know, can get a little granular when you zoom in on this one. Um, we're gonna cover these symbols today, these wind symbols. So, uh, don't worry if you are confused about these wind symbols. We'll cover those today. Um, but yeah, so what is the predominant visibility around letter A? So letter A is over here, and then visibility is shown. You got this little, again, it's kind of hard to read. Again, that's why the PDF would help. But these different shadings of colors show you whether it's LIFR in purple IFR in pink, MVFR in blue. So then over here in Western Washington and Oregon, we have mostly blue along the coastline, right? So that would be MVFR. This guy. These can be kind of hard to read too, unfortunately. But these are the figures you're gonna get on your FA exam. So they'll be on the computer when you take the written exam. You'll also have a physical copy of the figures with you during the exam. So again, that's kind of why I sent you the physical copy of the figures as well. But we kind of just have to live with these figures because they come from the FAA. But it says you're starting your trip Northeast Indiana, so we got to kind of understand where these states are, right? So but it does say the the 2-letter identification for each state. So Indiana's here. So Northeast Indiana would be like number B. What kind of cloud coverage can you expect in this area? So if we zoom in, we see it says OVC 060 and then top 070. That's going to tell us that we have overcast base at, and this is hundreds of feet. So 060, you add 2 zeros to that. So that'd be 6,000 feet overcast with tops at 7,000 feet. So the top of the clouds. So that would be this one. A little fuzziness builds resilience. Appreciate that. All right. So yeah, we got a first question's answer was C. I believe, did I get that wrong or something? Nick, is that what you're saying?
Yeah, I think he put it as B for rain showers. I think it was ice.
Hmm. Did I have the wrong symbol?
It wasn't that one. Or is that the first question?
Oh yeah, no, it was. So
Because
this
it's the
symbol,
triangle.
is that ice triangle with a dot in it?
I believe so.
Oh, okay. Yeah. Oh yeah, yeah, rain shower, you're right. Rain showers is the triangle with the dot on top. See, you don't use it, you lose it. Thank you. All right. Any other questions here? We got a lot of slides to get to, so I do kind of want to get to those. But I do also want to answer your questions. But we might keep the questions a little bit shorter today and then just have you guys, reach out to me through the text or in the group or whatever for any other questions, and I'd be happy to answer them. Random question, Nina. Do you currently fly or just focus on your website? I haven't flown, so I'm not current right now. So it's been a little bit. The goal is to fly again someday. Um, but the business takes a lot of my time, so I need to figure that out. So that's kind of the goal, is to build the business more, but give me some more free time so I can do that. As you guys know, flying takes a lot of time, especially when you do it right and safely. So I don't want to just do it to do it. I want to do it safely in the right way. But hopefully one day I'll be back up soon. All right. Well, let's get started today. All right. Today we're going to cover METARs, TAFs, PIREPs, winds and temperatures aloft, and we're going to kind of do an intro on airspace. We're not going to cover everything on airspace. So part of your homework is to go through those lessons on airspace as well as the quizzes, because we're not going to cover every single kind of regulation about airspace. We're going to cover some key ones and then have you guys go through the lessons, because airspace is a lot of rote memorization stuff. So we're going to hit it a few times, and then we'll do an airspace review, I think, next week as well, to hit it a few times. So that's kind of the goal with that. All right. So METARs. You can get this at aviationweather.gov as well as TAFs. So I'll show you guys real quick how to do that. But They stand for Meteorological Terminal Air Report. It's a routine weather report issued at hourly intervals and valid for an hour after they're issued. So let's show you guys what that looks like here. Where to go. So aviationweather.gov, you should just have that, saved. And then up top here, it says, I think here would be, so we can just go here, you can go. And then it's going to give us TAF here and a METAR. And then you click decoded and click go, and it'll kind of decode them for you a little bit. It doesn't quite decode everything, like remarks and things like that. It won't decode, but it does a pretty good job of decoding them for you, which is nice. So yeah, this is where you get METARs and TAFs for any station. You just have to know the airport identifier code. You can also do, you can kind of go back in history and kind of look for, whatever purpose you want to do that for. Pull this back up. Okay. Let me get my pointer. All right. So a description of the meteorological elements observed at an airport at a specific time. That's essentially what a METAR is. They can be a kind of a normal one, or what we call a specie or special. It's a special weather report issued for significant deterioration or improvement in weather conditions. So let's say between the hour where they normally just routinely come out, there's like a huge change in weather. Like let's say it comes out at 1 p.m. and it's like, hey, everything's sky clear, winds calm, blah, blah, blah. And then, like a squall comes in, just like crazy storm comes in at 30 minutes between the hour. They would issue a special, in that situation. They might issue a new one. Both are denoted by identifiers of METAR and specie at the start of the report. So we'll show that in an example. So you kind of know whether it's a special report or not. And if there is, then okay, the weather has changed rapidly. So kind of a good sign of bad weather, right? So here's some of the information that they could contain. So you got the airport name, where it's from, the issue time, wind direction, speed, gust, wind direction variation, visibility, runway visual range. So sometimes it'll tell you the visibility if it's a runway that's used a lot for IFR and it has, the visibility is less than a statute mile or something. They might tell you in feet how far down you can see the runway. That's a runway visual range, and it's obviously not for VFR pilots. Weather during time of observation, clouds, air temperature, dew point, the pressure, like for our altimeter setting. Weather during the past hour, but not at the time of observation. It can tell kind of trends of weather right here, trend type forecasts, wind shear information, and more. All right, so we'll kind of go over each one of these and show. This is the figure from the test supplement. So this, if you get asked about METARs on your written exam, it's going to be this figure. So if you just know how to read this whole thing, pretty much guarantee that you'll get those questions right. So as you can see, we got some METARs, and then we have a couple special METARs here. But the ICAO Identifier is the airport name. So ICAO is like the International Aviation Organization that kind of standardizes things like airport code. So that's the K, and then followed by usually something that has to do with the city that it's closest to or the area, like KLAX. That's like LAX, I'm pretty sure. Yeah. And then so yeah, that's going to be the airport identifier. Then we have the date and time. So that's going to be next here. The first two numbers are the day of the month, followed by the time in Zulu. So Zulu time is, if we do all our reports and things in Zulu time, that means no matter where you are in the country, you can just convert to your local time. So that's why they don't do like local time. So it doesn't get confusing if you're getting this in New York or Washington State or whatever. And then we do have a lesson. I don't think we've gone through that yet, but we will have a lesson where we practice converting times because you might get a question about that. But for now, just know that it's Zulu time. So this one right here, right? Or this example here, 212355 Zulu. Can you guys say in the chat what you think that tells us? I'm gonna ask for you guys to put in the chat quite a few times during this because I want you guys to get the practice of kind of guessing, not guessing, but figuring out what these are by yourselves. Yep, yeah, it'd be 11:55 p.m. Zulu, and it'd be on the 21st of the month. They assume that you know what month it is, so yeah, good job there. All right. Next one could be a modifier. So we don't see those here in this figure. But it could say auto or core. Core means corrected. So it might say, hey, this is an automated station, or just might not. And then you kind of assume that it is. I don't really know why they sometimes do and sometimes don't. But if you see core, that would mean that it's a corrected automated report. Like, I don't know what situation that would be, but just a little bit more information. Not super important, but that's what those mean. Next up, we have the wind. So the next thing, either after that modifier or the time, we have the wind. So the first three numbers of the wind are going to be the direction that the wind is from relative to a true direction. So one of the things for winds, we like to say, if you read it, it's true. So what that means is if you read wind information, whether it's on a METAR like this, or whether it's on a winds aloft chart, which we're going to cover today, it's in relation to true north. Okay. Now remember, we talked about variation. We talked about when we measure a direction on our charts, like a heading or a course on our charts, we're getting a true course because our charts are related to what we call true north. It's a 2D flat thing of our globe, so we have a different type of north. And then when we fly, we have to take into account the globe and what comes with the globe, the magnetic field. So we convert that using variation to a magnetic direction. Same thing for winds. Winds are a direction, so they can be true or magnetic, and we have to be cognizant at all times of what they are. If we read them, they're true. If you are to talk to ATC, let's say you're about to land and ATC tells you the wind on the runway, they're going to give it to you in terms of magnetic, because again, when we're flying, we want everything in terms of magnetic because everything is based off our magnetic compass. We calibrated our heading indicator to our magnetic compass, so it just makes sense. If we're, and our runways are, based off magnetic direction. So if we're landing on runway 21, we're flying in a magnetic direction of 210. And so if we are told winds are from 270, we know that, hey, okay, they're 60 degrees off from the direction we're landing in. So we got quite a bit of crosswind, right? They're not going to tell you over while you're flying winds and true, but when you read them, they are in terms of true. And when we get into flight planning, this is very important that you know this and you make sure you're comparing apples to apples, true to true and magnetic to magnetic. All right. VRB is variable, and then it's going to be the speed in knots. If the wind is gusting, it'll have a G, and then the highest gust will be displayed after the wind speed. So this first one right here, can you guys tell me what this reads for the winds? This METAR at KINK. Kinky. So Colsa is coming from 110 at 12 knots, gusting to 18. Yep, 110 true. Okay, good job. How about, let's do one more. How about this one at KMDW? Yep. Good job, Nick. Good job, Nina. Manish. Good job on that. What about KMDW? From 320 at 5 knots. 320 speed 5. Coming from 320. Yes. Okay. Good job. You guys got that down. All right. Next up is going to be the visibility. The prevailing visibility in statute miles. So statute miles is different than nautical miles. We use nautical miles when we talk about how far we're going to fly in flight planning. When we want to come up with a ground speed, we do nautical miles divided by time. The reason why we do nautical miles, so it came from nautical world, right? When they first started traveling the world in wooden ships, they came up with a new type of mile. And it's because when you travel long distances, you have to take into account the curvature of the earth. So statute miles is if you were it's a straight line distance. So it's like a tape measure distance from here to there. So that makes sense that we talk about visibility, we talk about statute miles, right? Because our eyes look in straight distances. So if we say, okay, we have something one statute mile away, when we're looking at it, it's in a straight line. Our vision's in a straight line, so it's one statute mile away. We're not, and then that's opposed to nautical miles, which we do when we're traveling long distances, like when we fly a plane. And so that's why there's a difference between statute miles and nautical miles. I think so. Statute miles is the number of feet. What is it? 5,620 or whatever feet. And then nautical miles is a little bit more. It's about 6,000 feet. 5,280. Thanks, Tim. All right, so may show additional visibility for a runway denoted by R and the selected runway, followed by / and the visibility in feet for that runway. So that's the runway visual range I was telling you about. We don't have any examples of that here, but we'll show you an example of that later. Could also see DSNT in place of visibility, and that just tells you that it's greater than 10 statute miles. It just means the visibility is good and distant. You can see very distantly. So it may also have fractions here, and the way they do the spacing is kind of confusing. It almost looks like it's a completely different set of data. So you kind of got to watch out for that. But this would be 1.5 statute miles. So this is the whole number, and then this is the fraction here. This would be half statute miles, 6 statute miles, 30 statute miles, 15 statute miles. Again, this DSNT would be visibility greater than 10. And then here's an example of the runway visual range. It would say like R36L /2400. So that's telling us the visibility is 2,400 feet for one runway 36 left. Okay, and again, that's mostly for IFR flying, not for VFR private pilot. Okay, so present weather may include, that's next, it may include density, intensity, descriptor, precipitation, obscuration, or other information. And we're going to go over kind of the symbols and different things that you can see. So first off, intensity, you could have a dash sign or a negative sign that's going to tell you that it's light. The intensity of what follows is light. No symbol would mean it's moderate. A plus would mean heavy. And VC would mean in the vicinity, which means within 5 miles. Okay, and we'll give some examples in a sec. Descriptors, some of these make sense, right? So DR, low drifting. So DR, that makes sense, drifting. BL, blowing. SH, showers. TS, thunderstorms. FZ, freezing. All these make sense. BC, patches, that doesn't make sense for English. MI, shallow. So it turns out that these come from the French word a lot of times. The French have a storied history in aviation, going back to like when the Wright brothers were figuring out how to fly. I think the French had a dude doing the same thing. So a lot of these words were originated in French, and so that's why you see BC is patches. I don't know the French word, but that's the reasoning behind that. Precipitation, you got DZ drizzle, RA rain, SN snow, SG snow grains, IC ice crystals, PL ice pellets. So all those make sense. And we got GR is hail. That's another French word. GS is small hail or snow pellets. Again, I think that comes from a French word. And then up is unknown precipitation. So that one makes sense. Obscuration. So these are things that would obstruct visibility. So BR mist, that's another French word. FG, fog. FU, smoke. That comes from like fume, right? Fume, which is French, or fume. I kind of know that French word. But that kind of makes sense, like fumigate and fumes, right? DU, dust. SA, sand. HC, haze. PY, spray. Not sure about that one. On the origination of VA, volcanic ash. Other PO is dust or sand swirls. SQ is squalls. FC is funnel or cloud. Plus FC is like a big funnel cloud, right? So that'd be like a tornado or water spout. SS sandstorm, DS dust storm. So those are just some other things that you might see. Now, if you're thinking like, oh my God, we have to memorize all of these, I didn't find it too hard to memorize these because a lot of them just make sense, right? ECSN, it's snow. So if you just kind of get used to those like French ones like GR hail and just kind of focus on those, I think your mind should connect the other ones just fine. So it's easier than it looks on these guys. All right, so present weather. So let's do some examples here. Right here at KLAX, what is this BR? That tells us something about the present weather. Can you guys say that in the chat? What BR means? Broken, mist, broken, baby rain, mist. Yeah, so broken is usually going to have a K in it as well, and then it's going to be followed by numbers to tell us where it's at. So that's how you can distinguish between broken and BR is mist. It's one of those French words. Oh, baby rain. I didn't when you said that first, I was like, I thought you were just calling mist baby rain,
Yeah, I
but
think that's a real thing, isn't it? I think that's a real.
is it?
Yeah, I think so. Yeah.
Yeah, well, I like that. Yeah, it helps you remember. Good. I like it. All right, so what about this one? What is RA? Rain. Yep, that one's moderate rain. Good. Good. Good job adding the moderate, right? This would be moderate mist as well. Because there's no minus sign or plus sign. Then FG, what about FG? Fog, 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 fog. Moderate fog, I guess. I don't know if they say light fog or I don't know. It seems like just either there is or isn't, but I guess you could have dense fog. All right, good job. You guys got that one. So sky conditions, it would be next. The first three letters tell the amount of sky covered. The following numbers indicate the height of the base of clouds in hundreds of feet. Whenever you see hundreds of feet, just add 2 zeros to the number. That makes it easy. If it's thousands of whatever, just add 3 zeros. That's an easy way to do it if you struggle with that. SKC, sky clear. That's kind of where that comes from, sky clear. That makes sense. You might also see SCLR. They kind of do them differently, manual and automated. I don't know why. Few means few. SCT means scattered. BKN, right? There's the K in there and the N as well. That means broken. And then OVC is overcast. So the definition of these few means 0 to a quarter of the sky is covered in clouds. Scattered means 3/8 to a half of the sky is covered in clouds. Broken is 5/8 to 7/8 of the sky is covered. And then overcast is total sky coverage. Only BKN and OVC are considered ceilings. So when you hear a ceiling, you know that you at least have broken or overcast. Anything lower than that is not considered a ceiling. All right. So what is the one at KBOI? I think that's Boise. K-Boy. What the sky condition here? SCT 150. What does that tell us? Scattered, yeah, but what do the numbers mean? Scattered at what level? 1500, 15,000, 1500. No, remember, add 2 zeros. 2 zeros. So this is 15,000. So it's scattered at 15,000 because it's 150, add 2 zeros, 15,000. All right, good. I'm glad we're doing this. Got some of you guys. All right, what about this one here at KMDW? It says OVC 007. What does that mean? Overcast at 700. All right, you guys got that one. Good. Yeah, add 2 zeros. So then this one down here would be overcast at 500. This one here would be scattered at 700. And then this one up here is just sky clear. All right, good. Okay, next up is the temperature and dew point spread. Excuse me. So first, you'd have the temperature in Celsius, and then it's going to be a slash, and then it's going to be the dew point. If you see an M, that tells us it's minus. I think they wanted to get away from doing minus signs because we now know minus sign means light. So I think that's why they put the M. I'm not quite sure about the origination of using M for minus, but that's what it means. So here, 2517, the temperature is 25 degrees Celsius and the dew point is 17. Okay, here's a question. Out of all these 5 different ones, which one or ones, maybe there's multiple, is the most, and these are the surface levels. So what are the ones closest to having some sort of fog or visibility issues due to moisture in the air? Or in other words, what are the ones closest to becoming the most saturated and having visible moisture? So you guys are saying KLAX and KMDW, KLX, KJFK, KJFK. Yeah, so KLAX and KMDW would kind of be pretty much tied because their dew point is so close to the temperature, right? So 16 degrees temperature, 15 degrees dew point. You know, you go up 1,000 feet and you're going to be at the dew point. So you're probably going to have clouds at 1,000 feet. Oh, look, scattered clouds at 700 feet, right? Same thing here, right? You go up just a little bit and your temperature is going to drop to the dew point and you're going to get visible moisture. Oh, look, low clouds, right? So this temperature dew point spread is a clue that you're going to have low clouds. Yeah, KJFK is pretty close, right? 20 and 18, that's really close too. Oh, look, overcast at 500, low clouds. Here's another runway visual range here. So runway 04 has 2,200 feet of visual range. Just another example of that in place of the visibility. Well, I guess there is visibility as well, but they want to give some information for those IFR pilots. Okay. Next is altimeter setting. It's going to tell us A and then followed by 4 numbers. So the A tells us it's altimeter setting or pressure in inches of mercury. So the 4 numbers, we can just assume that the decimal place, they don't give us the decimal, but we can assume there's a decimal place in between the 4 numbers. So we have 30.00 inches of mercury here. So if we're taking off at KINK and we get this METAR, we would obviously want to listen to the most update METAR both or ATIS before we take off. But let's say it tells us the same thing as METAR. We would set our altimeter to this number here, 30.00. This one 30.15, 29.91, 29.80, and 30.06. Which one is the closest to standard pressure out of all 5 of these airports? KLAX. Yep. 29.92 is standard pressure. So 29.91 at KLAX is basically that. Pretty dang close. Okay, next up we have remarks. Now, I'm not going to go through every single remark. We go through a lot of them. We have a couple tables in the course that can help you with remarks, but the FAA written doesn't ask a ton of questions about remarks. I've only known of a couple questions or heard of a couple questions that ask for information about the remarks, but there could be a ton of different information about remarks. We'll show some examples of those, but I don't want to spend too much time on them. And I think you guys should really focus on the meat of these. And then, maybe some of the ones that you see in our practice questions that ask about remarks. So don't get too caught up in memorizing all the remarks data. It's not something you'll be tested on extensively. But they could be, you know, they could tell you when a thunderstorm began. They give you a lot of information about trends. They can tell you temperature and dew point to 1/10 of a degree. So they might give you that like a little bit more, precise. Might tell you sea level pressure in pascals. They might tell you like how much rain has accumulated or been dropped in the last hour. Things like that. Just different information to add more data to the weather report. Okay, so we're gonna go through and do another example. So we have a METAR at Seattle, SeaTac Airport, KSEA. So can you guys tell me the month and time of day in Zulu? So yeah, it's going to be the 19th of the month at 17:53 Zulu, which is 5:53 p.m. Zulu time. Right? We just subtract 12 when it's above 12. You subtract 12 for the military time to get 5. So anything above 1200 means it's PM. And then you just subtract 12 to get the PM time. So that'd be 5:53 PM. Okay, good there. All right, what about the winds? What are the winds telling us? Cole, what do you mean Zulu time in Cali?
I think I'm confused on how Zulu time works because I don't.
Yeah, so Zulu time is always the same. It's a reference time that everyone in the world can use. So there's no, you know, so someone can look at Zulu time and then they can then convert from there to their specific location and whether or not, right, if you're whatever state you are, if it's daylight savings or it's not daylight savings, or what time zone you're in. That's when you take into a factor when you want to convert to local time. For now, we'll go over that later. For now, just know that like
Oh, so we're not converting to local time right now.
no.
Oh, okay, that's where I was confused. All right,
Yeah.
thank you.
Yep. No. Yeah. It originates on the time meridian, right? Which goes through UK. All right. So you guys for wins, you guys said 190, which is David said south southwest, which is correct. So 190 at 60 knots gusting to 22. Looks like you guys got that all right. Good job. All right, and then this one's pretty simple, right? 10 statute miles. What about this dash RA? What does that mean? Light rain, light rain, light rain, light rain. All right, you guys nailed that. Okay, how about all three of these? What are FU 018, BKN 023, OVC 033? What are those? Do all three. Cloud bases, yes. So, Sam, it's going to be, remember, add 2 zeros. So not 18,000, 23,000, 33,000. So K's got it. It's few at 1,800, few clouds at 1,800, broken cloud layer at 2,300, and overcast at 3,300. So you had 2 zeros. Okay, good. All right. And then what about 12/09? What does that mean? If you can't type fast enough, you can just, say it out loud to yourself and um, see if you got it right. 12 degrees Celsius, 2.9 degrees Celsius. Yep, got that. All right, and then what is A2982? Altimeter 2982. Inches HG, yep, inches of mercury, 2982. Okay, looks like you guys got that. All right, so remarks. I'm not going to quiz you guys on the remarks, but I will tell you what this means as an example. So the A02, this tells us information about the station. It could be A01 or A02. A02 says that it doesn't have a sensor to tell us how much precipitation. It's like it doesn't have a certain precipitation sensor. PKWND followed by these tells us the peak wind, what it is and when it was. So this tells us that peak wind was from 190 to 29 at 1717 Zulu. So this is interesting information, right? We're at 1753 Zulu. This is about, what, 30 minutes later or so. And it was up to 29 knots, right? So it's come down from that, still gusting, but tells us, within the hour, within the half hour or so, the winds were really high. And if they were really high within the half hour, it could be possible, especially with this gusting. So, if you're looking to decide whether or not, you should fly, or if it's over your crosswind limits or whatever, this could be more information to tell you that. RAB is going to tell us when the rain began in minutes past the hour. So the rain started at 53 minutes past the hour that this report was made. So it just so happens that the report was made at 1753. So that's apparently the rain just started the minute that this was made. Sea level pressure. This is in tenths of hectopascals. This is the same thing as this, but this is in inches of mercury. So tenths of hectopascals, this would be 1,040 hectopascals if whoever was looking at this wanted it in hectopascals. This is going to be the hourly precipitation in 1/100th of an inch. So this is all zeros. And I think this goes with this note here that they don't have the ability to measure that, or maybe, that kind of confused me here, but basically in the last hour, there's been no rain. And then maybe, hey, the rain just started at 1753. So it hasn't been any rain less. This one, the 60005, this tells us the amount of rain in hundredths of an inch for the last 6 hours, the total in the last 6 hours. So we've had 0.05 inches of rain in the last 6 hours. And then we have this one right here, T011, all that jazz. This is the temperature and dew point spread. So, but it adds another decimal place. So, there's 4 numbers, and that'll be your temperature. And then there's another 4 numbers, and that'll be your dew point. The first 2 just tell us if it's a 1, it tells us that it's, let's see here. If greater than 0, if the first digit is greater than 0, it tells us it's a positive number. Right? Let me see if I'm reading this right. And then if it's less than, then if it's less than, if it's 1, it means it's less than. So if this first digit is a 1, it's a negative number. So these first digits are 0, and then the next 2 is the whole number, and then you just add a decimal here. So it's 11.7 positive is our temperature. So that kind of fits with up here. We just rounded up to 12. And then the next set of 4, the first one is a 0, so we know it's positive. If it was a 1, it'd be negative. And then 8.9, just add a decimal. So that fits with 9. So 8.9. I don't know why you would want to know that, but anyways. Would sea level pressure 104 equal 10.4? Did I do that wrong? I always get confused on that. Is that the rule?
That's what I was trying to understand. I think so. I watched your video and I think I understood it, but I just wanted to double check that I was
Okay.
getting that right.
If I said it in the course, I would go with that because I forget what it was here. So what is the rule? I'm trying to look here and trying to remember. So it's you just add.
You move the decimal over and then you figure out if putting a 9 in the front is closer to 1,000 or if putting a 10 in the front is closer to 1,000.
That's right. It's really confusing. Yeah. Okay. Yeah, because this could be. There's examples where this is like 987 or something like that, right? Is that right?
Yeah, so it would be 98.7, and then you decide if you put a 9 in the front or a 10 in the front. And in that case, you would put a 9 in the front because it's closer to 1,000.
Gotcha. Nice. Thank you. Yeah. So AKA just don't worry about that. Yeah, thank you. All right, so enough of the remarks. Those are already making my brain bleed. Okay, TAFs. All right, so that was METARs. TAFs are basically same as METARs, but forecast weather. METARs are actual weather reported. TAFs are forecasted. They slightly different format than METARs, but mostly the same abbreviations and decodings. They give the expected weather to exist at your destination at your estimated time of arrival within a 5 statute mile radius from the reporting location. So within 5 miles of whatever airport or location that it's for. They're issued 4 times a day and usually valid for 24 hours, but some TAFs, like those for large airports and bigger aircraft and longer flights, are valid for 30 hours. So it depends on the airport. They generally consist of 5 sections from left to right that include, again, the ICAO identifier for the airport, the date and time of origin, a valid time period, which we'll talk about. So you have a time of origin, you have 2 different times, time of origin, valid time, and then you're going to get the forecast meteorological conditions. So wind, visibility, weather, sky condition, and maybe some other data, just like we saw in the METAR. But you're also going to get some change indicators, and that's kind of where it gets confusing. So let's go through some examples. So we got same as METAR, we got the ICAO identifier. So right here, the KMEM or KOKC. I'm guessing it's Memphis and Oklahoma City airports. Then we have the date and time of origin. So that's going to be these next set of numbers here. So first 2 numbers are the day of the month, just like in the METAR. Next 4 numbers are, again, military time in Zulu. And it has a Z there to let you know there's Zulu. So this would be 12th of the month at 1720 Zulu. All right, next is going to be the valid time period. So the valid time is the amount of time the forecast covers. Even though TAFs are updated about every 6 hours, they usually forecast for 24 or 30 hours. The first 4 numbers are the start of the time period. So you would have the first 2 numbers of this first set of 4 is the day of the month, and the last 2 numbers are just going to be the first 2, the hours. And I'll show you an example. And then the last 4 are going to be the end of the time period. So again, the first 2 numbers are the day of the month. The last 2 numbers are the hours. It doesn't give you the minute, just goes by hours. So we have 1218/1324. So this valid time period is from the 12th of the month at 1800 Zulu to the 13th of the month, the next day at 2400 Zulu. So this one is good for 30 total hours, right? So on the 12th at 1800, which is like 6 p.m., all the way to midnight at the end of the night on the 13th is when this is valid for. So if you're looking at this TAF and you're wanting to fly on, let's say, the 13th, the morning of the 13th, you would know that this forecast is considered valid for that time period. This one down here, 0512 and 0618, it's on the 5th of the month from 1200, so at noon, all the way to the next day on the 6th of the month at 1800. So again, that's another 30-hour forecast there, time period. Okay, so then we have the meat of the forecast, which is those meteorological conditions that we talked about. And so we have wind, visibility, weather, sky conditions, optional data such as wind shear, which we'll kind of get into an example. They're almost identical to METARs, but TAFs will only report cumulonimbus clouds. And the sky condition on a TAF will only report the lowest ceiling. So remember, ceiling was only broken or overcast layer. So it's not going to tell us things like scattered or few. It's a little bit less data. It's a little bit harder to forecast like few clouds, right? So it's only going to tell us when we have broken or overcast clouds. And then the only clouds it might talk about is cumulonimbus clouds. And the reason why is because those are vertically developing clouds, which gives us turbulence and thunderstorms and all sorts of dangerous conditions. So that's why they only report those types of clouds. And they'll only show you the lowest ceiling value. So they're not going to show you like, broken at 2300 and overcast at 3300. They only tell you the lowest ceiling value. So they're trying to just kind of be more condensed in a TAF. All right, so you may also see a prob followed by two numbers. And this is telling us a probability in terms of percentage that the following will occur. So they have these computer models, right, that say, forecasts are all based off statistical models and things like that. They're getting more and more complex. And so they add a probability number to that. So if I said like prob 30, it's a 30% chance that what follows is going to actually happen. Okay, so it just kind of gives you a little bit more idea of how likely it is to occur. If you see a 9999, 4 nines in the place of visibility, it means the visibility is 7 statute miles or more in a TAF. I don't know why they don't do just the same DSNT like in a METAR, but they do 9999. Visibility listed without statute miles is going to mean it's in meters. So if you see maybe near the border in Canada where they share, with Canadians, they might give it to you in meters. I'm not really sure when that would be, but that's what that means. If you don't see the SM, it's in meters, just to confuse you even more. All right, if you see an FM or a tempo, this means, or a BECMG, which I'll get to, this means that the original forecast before this part will be changing. So these are called change indicators, and I left out, I should have put in BECMG, that's another one. So FM or from is used when the weather will change rapidly from the prevailing condition in less than an hour. Anything after the FM is now the new main forecast. The time format starts with the first two numbers being the day and the last 4 numbers being the time. And we'll do examples, so don't worry about that. But after the FM will be the new main forecast. Okay, I already said that. Tempo or temporary is used when the weather conditions will last less than an hour, has a greater than 50% probability of occurrence, or will cover less than half the period of the TAF. So it's like a temporary type thing, right? The time group of the tempo when seen with 2 groups of 4 digits. So you can either see it 2 different ways. You might see just 1 group of 4 digits or 2 groups of 4 digits with a slash. When it's seen with the 2 groups, it's exactly the same as a valid time group in that for each group of the 4 digits, the first 2 is the day of the month and the next 2 are the time of the day. So on the 20th at 1800 Zulu to the 20th at 2000 Zulu. For these 2-hour periods, it's a temporary kind of forecast. If you just see 1 group of 4, it's only the time in Zulu for that assumed day. So it's 1417 Zulu for the assumed day of the TAF. Okay. You may also see BECMG. That means becoming. It's used when there is a forecasted gradual change in weather. So it's like slowly becoming. You can think of during the time group that follows to the depicted weather that follows. So the time group of the BECMG works the same as the tempo time group. So it could be, again, it could be these 2 sets or it could be just 1. Let's do some examples. All right. So we're going to go through the entire KMEM1 for you guys. That's this one up here. So can you guys tell me this 121720Z, what that means for the TAF? The 12th at 1720 Zulu. Looks like you guys got that. So that is the date, or the, what did they call that? The origin time. So that's when the TAF was made. Okay, now what is this next set? 1218/1324. What does that tell us? And yeah, 5:20 p.m. was this as well. So 1720 Zulu or 5:20 p.m. Zulu. So yeah, this next group is a valid time. So it's the 12th at 1800 or 6 p.m. Zulu to the 13th at, oh, I already said that one, but yeah, so you guys should get that. All right, good. Looks like everybody got that. All right, what about this next one? 20012 KT. All right, wind from 200 at 12 knots. Looks like you guys got all that. Next up, 5 statute miles, right? All right, what is HZ? Haze, 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 haze. You guys got it. That's a good one. All right, next up, and again, you can only see, right? There's only one cloud layer, right? So BKN 030, that's going to tell us what? Broken layer at 3000. And again, there could be more cloud layers, but the TAF is only telling us the lowest one. So the ceiling, and it only tells us the ceiling, whether either broken or overcast. So we have a ceiling at 030. We could have a lower cloud layer that's like few. We could have few clouds at like 1500, but it's only going to tell us the lowest ceiling, either broken or overcast. All right. My computer's making noises. I just want to make sure. All right. Next up, we have prob 40. What does that tell us? Probability 40%. Okay. Of what is to follow. So anything after this, until we get another, identifier, or change identifier, like an FM or BECMG, what follows the prob is what it's talking about. So this group right here has a 40% chance of happening. Okay. So 1220/1222, what does that tell us? So it adds a little more data to this probability, right? It says from the 20th, or sorry, from the 12th, give you guys a chance to get it. Yeah. So from the 12th at 2000 Zulu, from the 12th at 2200 Zulu, for those 2 hours, you have a probability of 40% chance of 1 statute mile visibility. What is TSRA? Got thunderstorm and rain. Thunderstorm and rain. Thunderstorm and rain. Thunder, rain. Yeah. Yep. So it's thunderstorm and rain. And then next you have OVC 008CB. What does that mean? Overcast 800. CB. We got cumulonimbus. We got clouds broken. Now you're good, Cole. But yeah, so it's cumulonimbus. So overcast layer at 800 feet, cumulonimbus cloud. So this whole thing right here is telling us for this 2-hour stretch from 8 p.m. to 10 p.m. on the 12th, there's a 40% chance of some severe weather. There's some thunderstorms with low ceiling and low visibility, right? That's what this is telling us. All right, moving along. FM 122200. What does that tell us? Yep, so it says from 2200 Zulu on the 12th, which is also 10 p.m. So from means that we're going to have a rapid change in the weather starting at that time. Okay. And so that what follows is what is going to be the new forecast from 2200 Zulu on the 12th. That's kind of right after this grouping here. You can kind of build a timeline in your head. So we have 33015 G20 KT. What does that tell us? Yes, this is the only chart on the exam for TAFs. Yeah, so we got winds from 330. And again, that's a true direction at 15 knots, gusting to 20 knots. And this gust, that's the highest gust factor that they've observed or they expect. I guess they haven't observed because it's a forecast. All right, now P6SM. I don't think we've covered what one of these with a P in it before. Does anybody know what P6SM means? Okay, says +6 statute miles. Psalm says more than 6 miles. Darren says K knows. LOL. You still need to participate. Can't just let K answer everything. Just kidding. All right, yeah. So it's plus or more. It's 6 nautical mile, or sorry, 6 statute miles or more. So technically more than 6 miles. But anyway, 6 statute miles or more. That's what the plus, like +6 miles of visibility. Wait, I'm looking up here. Sorry, there's another P6SM. All right, and then we got BKN 015. That's broken at 015. And I guess they did put another cloud layer here. I'm not sure if that rule I said before sticks all the time, but this BKN 015, that's broken at 1500. And then overcast at 2500. So maybe they don't just put the lowest. I'll have to look into that. Let me write a note for that. They're always changing the rules. TAF only report lowest. Question mark. All right. So yeah, you guys got it. Broken at 1500, overcast at 2500. Good. Then we get into another 40% probability. Again, it's from the same time frame. So I think what we're doing here is we're saying they're kind of updating this here with a little bit. I'm not quite sure why it's the same. Does anybody know why it's the same time frame as up here? Why it's repeated? Do you guys get what I'm saying? Okay.
Maybe it's 40% chance that one thing happens and 40% the other thing happens at the same time.
It could be. Yeah.
Because it's not improbable if you look at it.
Right. I kind of like
And
that.
the other 20% is random acts of good weather.
I like that. No, I think you're onto something there. So I wrote a note. I'll look that up and I'll post it in the recap.
Yeah, it's what Nick said. End of the world for the 20%. It's too bad there aren't abbreviations for it.
Yeah. Armageddon, ARMG.
Yeah, ARMG for sure.
All right, so let's go with that, and then I'll look that up for us and put it in the recap, in the notes part of the recap. Yeah, maybe different times release. Yeah. Okay, so let's continue on. But so we got another 40%, same time zone. We got 3 statute miles, and then SHRA. It's a little bit different than TSRA. Showers, rain. So yeah, what we're thinking is it says, okay, there's a 40% chance that we got 1 statute miles with a thunderstorm starting at 800 feet, or it's just, not quite as bad visibility and it's just rain showers. So we're gonna go with that, and I'll look that up. All right, next up we have another from group. This says on the 12th at 0200, we have wind at 350 at 12 knots, and then overcast at 800, and then another probability of 40%. This is a different time frame here. So for this one, it's again this from here. It's telling us, I wrote a note here, weather's changing rapidly from what we previously had forecasted. Now, yeah. So I looked this up because I was like, well, why do we have 1202? So we have 0200 to 0500 on the 12th, but that's not even within this valid time period, right? So this kind of got me confused. So this can happen. So what they do is they kind of combine forecasts sometimes if they think it's still relevant. So if this was, let's say, on the previous forecast where the valid time was, where this fit within the valid time, this 0200 to 0500, and they had this weather, they might keep it in there if they think it's still valid. They can kind of combine forecasts. So you might see some of these probability, from things happen that are outside of this valid time range. Okay. So that if you're wondering, like I was, what that means, that's what it means. So what do we have here? We kind of got a new thing, 2SM-RASN. What do you think that means? Yeah, so 2 statute miles and light rain and snow. And the minus sign is the light part. And again, it's 40% probability of that. Then we have a BECMG. So this weather is becoming. So slowly it's gonna, on the 13th from 0600 to 0800, we got some change in the weather, right? So we have 02008 KT. What does that say? Winds from 020 at 8 knots. Yep, you got that. We got a broken layer at 1200. Then we got another change identifier. That weather is now becoming at 1000 to 1200. So 10 a.m. to 12 noon on the 13th. We have a bunch of zeros, KT. So we have wind is calm. Yep. Calm winds. So no winds, basically. 3 statute miles. Then we have BR and then SKC. What do those two things tell us? Yes, all times are in Zulu. So 3 statute miles visibility, baby rain, which is mist. I like that. And then sky clear. Okay, and then we have a tempo. Again, this is a temporary forecast from 1200 to 1400 Zulu on the 12th. Half statute miles of visibility and fog. So again, the tempo, if I go back here, it has a greater than 50% probability of occurrence. So kind of the same thing as saying prob, greater than 50 is the tempo here. And then these probs are very similar to tempo, but just with less probability. All right, then we have one more from on the 13th from 1600. Weather is changing rapidly to variable. So we had calm winds, right? And then now it's VRB, which is variable at 6 knots. And then again, we have that plus 6 statute miles and then sky clear. Does anybody know what this equal sign means? Yeah, so oops. So David says fog. Yeah, I was confused at this as well. And I thought, oh, that's a symbol for fog on charts, right? But it actually means the end of it just means the end of the forecast. You can see it here as well. And sometimes these are all kind of jumbled together. So it's a visual identifier of the end and the start of a new one when they aren't like that. Okay, so we went through all of that. So David said, are the observations required to be sorted by time? I think they generally flow by time, but as you can see, I don't think it 100% was by time, right? We had this probability here that kind of jumped. So it not 100% sorted by time. By update, maybe. Yeah, I think they kind of just add to these. Right? So at one point maybe it was just what's down here or up here. I'm not sure. Yeah. I'll look into that as well. See if I can find any information for us. But clearly this one is not, so we know that they're not always. Okay, any questions on TAFs before we kind of move on? No, so Zulu time is different than military time. That's a good question. So military time is just the format of 4. Right, it's from 0 to 2400. That is military time. So instead of saying AM and PM, we just say, right, we just say 1720. Instead of saying 5:20 p.m., we say 1720. That's military time. Zulu is like where the time is, and it's again, it's the time meridian that goes through the UK, right? That's kind of the Zulu time. And we'll have a lesson on this in the future when we get to like cross country planning and stuff. Yeah. So Zulu time is given in that military 4-digit, right? 24-hour, 2400 clock. But it's standardized, as Ivan said, to UTC, which is just like a one standard time clock that we all work off. And then you can start there and then you can convert to wherever you are locally. Good question. We'll do, and don't worry, we'll get to there. We'll do lots of examples on that. All right, so let's talk about PIREPs. A PIREP or pilot report, right? They just kind of combine those two words, is a report of actual weather conditions as observed by pilots. And you can get them again from aviationweather.gov. So if you go, let's go take a look. You can go. They're here. PIREP. There we go. PIREP data. So again, you can just you can do an airport center or something. I think, oh, yeah. How does it search? It's not, is it, okay, is it by airport? There we go. So you can put an airport or you can type in the center. But this is where you would get a PIREP. And yeah, ForeFlight does a lot of this stuff in ForeFlight. So that's one of the benefits of ForeFlight. They're very useful, especially when they have been submitted recently because they depict true conditions at exact locations and altitude for specific aircraft. Okay, so for certain pilots, it's just can be very, especially like general aviation, it can be very, very helpful to know that a pilot had these, it's hard to forecast things. It's hard to know, you might have a weather station on the ground, but you don't have a weather station floating up at 5,000 feet, right? So they can, one thing you'll realize as you get into flight planning, you go up and fly, your weather data is going to be wrong all the time. Okay. So we can do the best to understand what kind of conditions to keep ourselves safe, to be able to make, go, no go decisions. But once we're up there, things can change a lot. And that's why PIREPs are so useful. Pilots can make PIREPs to a flight service station while in the air over the radio, or they can call and make a report online after landing. PIREPs are issued whenever a pilot makes or reports one. That's kind of obvious there. They use similar abbreviations as a METAR TAF, so you don't have to learn like a whole new language. That's good. But they do have a distinct format. So that's what we're going to cover here. So you have, first off, the station identifier. So it's the first three letters of each PIREP is the station identifier. So it's the nearest weather reporting location. Let me get that laser. Weather reported location to the reported weather made in the PIREP. So if you're flying near, a weather station on your map, FSS station, and that's the nearest thing to you, or it's an airport, that would be what you would submit in the PIREP, and that would be, it tells people the general location of where it is, right? So that's here, KOKC, and they even have to K-Tool. So kind of in between these two airports. So that's what we have here. And then we have the report type can be UA, which we see here, UA, or UUA. UA is a routine PIREP, while UUA is an urgent PIREP. So we have just a routine one. Urgent would be like if it has like really dangerous conditions, right? All right, next up, we're going to have location. So here's where the format you kind of got to understand the format. They'll have forward slashes followed by two letters that tell you what is coming next in the data. So you see, okay, we have a regular PIREP, right? It's not an urgent one. And then we have a forward slash OV. So now everything until the next forward slash is going to be the location. So OV tells us what follows is the location relative to a VOR. Or this could say VOR or station, right? KOKC and K-Tool. So those are the stations. So I could say, I should say, or station there. But usually it's going to have a VOR at the station. So the first three letters after the /OV is a VOR station. The first three numbers, or the weather station, right? FSS, first three numbers following the station is the magnetic direction from the VOR. So right here in this example, we don't have that, but you could see like KOKC followed by three numbers. It could be like 020. And that would be, tells you the radial from that VOR station that the person was on when they made that report. Okay. So it kind of gives you a little bit more data as to in relation to this location where they were. So if it was like KOKC 0, what did I say, 020, then you would look at your chart at OKC and you look for the 020 radial coming off that and say, okay, in this direction, that's where this weather was. And then it could also say the amount of miles from the VOR station too would be even more helpful because it's telling you the exact location. So along that radial, let's say 10 miles. If it was 010, it'd be 10 statute miles. And on that radar, that's where the pilot made that report. All right. Next up is going to be /TM. That stands for time. So everything after that is the time of the PIREP. So it's going to be in 4 numbers and it's in Zulu time. Okay, so we have /TM 1800 Zulu. Pretty standard. That's when the report was made. Next up is /FL. That signifies what's altitude. What's next is altitude. So the next thing we see after the /FL, you can think of flight level for that. So that's the flight level or altitude where that report was made. So where that pilot was when they experienced that weather. And the 3 numbers after that are the altitude in hundreds of feet. So again, add 2 zeros. So we have FL 120 /FL and then 120. So add 2 zeros to that. That's going to be 12,000 feet was where this person made this report in between KOKC and KTUL. All right, next up we have the /TP. Now this is really important and another reason why PIREPs are a little bit more helpful than maybe like a TAF or a METAR, right? 1, they're actual data, but 2, they have this aircraft type. Tells us what follows is the type of the aircraft the pilot was flying in when they made this report. It's important to know this because certain weather affects different aircraft differently, right? So certain levels of icing might affect a Boeing 737 a lot less than it would affect our little Cessna 172 or 152, right? It could have a really detrimental effect on our aircraft, but it's not really Boeing. They're used to it, right? They got things covered for that. Same thing with turbulence, right? Moderate turbulence can be hell for us. A Boeing might not even feel it because it's just so big and heavy that those little pockets of turbulence wouldn't even affect it. So that's why this type of aircraft is important. So this is like the type. It's the type number. So BE90. I don't know what that is, a Beechcraft or something. I'm not sure what that is. Maybe you guys do, but that's that. You can look it up and see what kind of aircraft and how big it was to give again more data to how it affected that pilot. All right, next up is we don't see it here in this example, but you might see next is a /WX. So that again, that's kind of easy to remember. WX tells us what follows the weather being reported in the PIREP. It can be visibility, precipitation, restrictions to visibility, and more. Again, we don't see this in this example, but here you might see like RA, like rain, right? That would be an example of weather. Beechcraft King Air 90. Okay, I was right. Nice. All right. Next up we have the SK. This is sky, so that fits. SK, that's easy for us to remember. Tells us what follows is the sky conditions and cloud layers in the PIREP. So here we have SK, we got BKN 018, and then we got a dash. This dash here doesn't tell us whether it's light or not. So PIREPs don't do the dashes and pluses for light and heavy. So just kind of remember that. They do dashes and I don't think they do pluses, but they do dashes to signify like we have broken and it goes to the top of the cloud. So broken at 1800 to tops of 5500. Again, another reason why PIREPs are really helpful is this is probably a lot more accurate, right? Pilot probably flew through these and was like, okay, well, it starts at 1800 and then at 5500, that was the top of the cloud. So again, it could be a little bit more detailed for pilots. And then it says, okay, we got more. We got overcast at 7200 with tops at 8900. So we have another layer after that. Clouds are an MSL, yes. All right, next up we have temperature, which I don't believe. Right here, the /CR is just saying above that it's clear. And then you got the ABV, that means clear above. All right, then we have /TA. That's going to tell us what follows is the temperature in degrees Celsius. And M tells us that the temperature is negative or minus. And again, this is the temperature at the altitude. So it's -7 degrees Celsius at 12,000 feet, the flight level where this PIREP was made. Then we have WV. So WV is wind. You can think of like wind velocity, but it's also going to give us the direction as well. So same as always, it's just not going to tell us KT, but it's in knots. So 08021 is wind from 080 at 21. And then we have /TB, and this is turbulence. So this is a unique feature of PIREPs. The letters following the TB can be either light, moderate. So LGT means light. MOD means moderate. My mouse is kind of freaking out. SEV is severe. And then EXTRM, they basically spelled the whole word, is extreme. Okay, so you can have these different types. There can also be a range of turbulence intensities reported with a dash in it between them. For example, LGT-MOD would mean it's light to moderate turbulence. And there are some definitions which are in the lesson in the course. I'm not going to go over them, but they kind of give definitions for each of these. So LGT, like, what does that mean? What does light turbulence mean? And it kind of all has to do with like control of your aircraft, control of a small aircraft. So like light would mean you can like maintain control, but it's going to be like small bump. Don't quote me on exactly this, but moderate would be like possible loss of control, but usually it's just going to be uncomfortable. Severe would be like likely loss of control in a small aircraft, and then extreme would be like, the worst you can imagine. All right, so turbulence, also included with turbulence, can be the type of turbulence. CHOP or CAT. CHOP stands for choppy, and then CAT stands for clear air turbulence. Again, I have more definitions of what that is inside the lesson. I'm not aware of any FA written questions on that, but it is good information for like your check ride and things like that. And then finally, an altitude range may also be included in hundreds of feet, just as in the flight level reports. It might tell you the altitude at which, or the range in which they experience that turbulence. So down here we have LGT 055-072. So we have light turbulence from 5,500 to 7,200 is what this Beechcraft 90 experienced, right? That gives us more idea the size of the aircraft and, okay, they felt light turbulence in this size of an aircraft versus this size of an aircraft. All right, next up is /IC. That's icing. Tells us what follows is the reported icing conditions for the PIREP. Just like turbulence, there's a range of icing intensities that can be reported. So there's trace, which means trace amounts. There's LGT, which means lights. There's mod, which means moderate, or SEV, which means severe. An altitude level may also accompany the icing data, just as it did for turbulence. So the type of icing may also be reported. You have rime ice, clear ice, or mixed. Rime icing is like rough and milky ice formed by the instant freezing of supercooled drops of water. It's kind of more visible, like it's milky. Clear ice is kind of clear, it's glossy and translucent, and it's like a slow freezing process. So it hits your aircraft, and then the airflow kind of moves the moisture over your aircraft, and as it spreads it out over the aircraft like a butter knife, it freezes, and so it's much clearer and glossier and harder to see. And then, so if you see like clear ice, kind of be a little bit more on the lookout, because rime icing, you could like see that on your aircraft if you look out the window, where clear icing might be harder to see from the cockpit. And then mixed is a combination of both. So here we have icing light to moderate. The type is rime, and it's from 072 to 089, so 7,200 to 8,900 feet. This example doesn't have any remarks, but if it does, it would say /RM. It tells us what follows as remarks. May include several different things. Could be wind shear, tornadoes, thunderstorms, lightning, volcanic eruptions, etc. All right. Any questions on PIREPs before we move on? Okay. So let's go on to winds and temperatures aloft. All right. So each winds aloft report has a WMO, which stands for World Meteorological Organization identifier code. It's kind of like ICAO identifier code. So it's right here, this FD10C1. Each grid of temperature aloft data is going to have its own. It's just an identifier, like a serial number. And then you could see winds aloft also be called FDs or even FBs. So you can see there's an FB or an FD. So the F stands for forecast, and then the B and D is just like an identifier. FA is like used for area forecasts. So it's not really important. Just know if you hear of like FB forecast or FD forecast, it's referring to winds and temps aloft. All right. So then as we're kind of going through these notes here on the top, you're going to have the date and time that the data was based on in the form of 6 letters followed by a Z, which stands for Zulu. So the first 2 are the day of the month. Next 4 are the time of day in Zulu. So we have on the 19th at 1200 Zulu. Okay, so that was the date and time that this data was based on. Then we have a valid date and time followed by a for use and another time. So we have a valid date and time immediately followed by for use between 2 times, so another time period. This means you can use this information between the for use times, but the forecast is based on the valid time. So it says, okay, it's valid starting here, and then you can use it between any of these. So really, for us, we really just want to look at the for use time and say, okay, if we're planning to fly during this time, then this works for us. All right, and then the final note is just temps negative above 24,000. So this particular example only goes up to 24,000, but there could be more, like 30,000, 33,000 or whatever. And all those are not going to show this dashed line to signify negative. It's just going to be 1-4. And we just assume that anything above 24,000 is negative temperature because it's so high, it's going to be. Does the FA still have this available? Yes, I can show you. Let me show you that. Well, it's on the aviation weather. So if we go to right here, so wind and temp data under products. They actually got rid of these when they first rolled out this new website, and people were like, hey, I want it back. And then it came back. You can pick low to high. So low is going to give you everything up to 24,000 feet. And you can see this is what it looks like if you do. I guess it depends, but high will go even higher than that, right? 45,000, 53,000. But yeah. And then you could even do different forecast times. So you go up to 24 hours and you'll get different numbers. Yeah, they did for a second, but they brought it back. All right, so let's see here. So the first column here, right here, it's going to list the 3-digit area of the forecast. These are normally based on major cities. So these aren't necessarily airport codes. They're usually based off like cities. I'm not sure what this would be, but there's a figure that you can use that kind of shows all the different reporting stations and what these mean that you can look up. Top row here, it says, let me get my pointer going again. So we got FT and then this top row. This is kind of the header column for the header row for all these columns. These are the feet, right? This is just the altitude in feet. So again, MSL, so 1,000, 1,500, 2,000, 3,000, 6,000, 9,000, and so on. Winds aloft aren't reported within 1,500 AGL of a station. So, and 2,500 feet AGL for temperature. So, for example, if a station, let's call it XXX, is at 2,400 feet MSL, there will be a blank entry in the 3,000 foot column for wind and temperatures because it's within 1,500 feet. So for example, we have the Rocky Mountains area, right? So we got a lot of stations that are high up in elevation. So this PRC, it's within 1,500 feet, the elevation of 6,000. So it's not going to give us data for that because you would just use the surface forecast for that, right? This is just a loft forecast. So if it's within 1,500 feet of a station, it's not going to give you the wind data. If it's within 2,500 feet, it's not going to give you the temperature data, but it would only give you the wind data like here, the PHX. Okay, so 9,900, which we'll get to in a sec. I'll tell you what that means. But as you can see, it doesn't have temperature data because it assumes, you know what, you're close enough to the surface, just use the surface temperature. All right, for altitude columns 24,000 feet and below with temperature data, the numbers for each station are decoded as follows. So there's going to be the first two numbers are going to be the wind direction relative to a true direction rounded to the nearest 10 degrees. Okay, so it's true direction because we're reading it. So it's in relation to true, and it's rounded to the nearest 10 degrees. So not super definitive, rounded to the nearest 10th. It's kind of an estimation, which makes sense when you're up there. It's hard to forecast winds aloft. And so it makes sense that we would just kind of give general directions. Next up, the next two, these YYs, that's going to be the wind speed in knots. And then it's going to be followed by either a plus or a minus. And again, this is only for 24,000 and below. Once you're above 24,000, you won't have a plus or minus. It's just assumed that the next two are the temperatures and that they're negative. But for 24,000 below, it's going to either have a plus or a minus to tell you whether the temperature is positive or negative. So let's kind of quiz you guys here. All right, so we're at this JON here. And as you can see, for 1,000, 1,500, 2,000, and 3,000, there is no temperature. Again, because it just says it's close enough to the surface, just use the surface temperature. So for the 3,000 foot column at JON, what does 1021 tell us? Right here, it's 1021. Yeah, so winds from, again, it just tells us the first two digits of the wind direction. So if we go back, first two numbers of the wind direction relative to a true direction and rounded to the nearest 10th. So rounded to the nearest 10th, so winds from 100 at 21 knots. So some of you guys got 19 or 090. This is 100 at 21 knots. Okay, what about this one here? KWA at 9,000 feet. What does that tell us for wind direction, speed, and then we have temperature data in this one? Winds from 320 at 9 knots, and temperature is 10 degrees, positive 10 degrees Celsius. Okay, good job. All right, let's continue on. You guys did good there. 320, 9 knots, plus 10 degrees Celsius. Yep. All right, for altitude columns above 24,000, like I said, they're going to not have that plus or minus. So it's just going to kind of look like this. And the last two, temperature, you just assume they're below zero. So let's do an example here. What is MDY at 34,000 feet, right here, this one? What is that telling us? 291441. Winds from 290 at 14 knots. And we assume the temperature is negative and it's 41, so minus 41. Yep. All right, good job there. All right. If you see a 990 for the first 4 digits, this signifies the winds are light and variable. Light in this case means less than 5 knots. So if you can see right here, this Phoenix 990. That means winds are light and variable. Also here, winds are light and variable. Okay, now sometimes you'll see a wind direction be a number that is greater than 36 or 360 degrees. This obviously doesn't make sense. It's not possible. And this is, they were really into like saving space and data way back in the day. And this is actually for a way for the table to represent wind speeds above 1,000 or 3 digits with only saying 2 digits. So let's look for an example. So here's TTK 99031. The 990 again means light and variable. It's above 24,000 feet, so it's minus 31, okay? So that's the 990 example. Well, this one right here, 760158. So what the heck does that mean? Does that mean winds are from a direction of 760? No. What it tells us is when this is greater than 36, which would be the maximum, like 360 degrees, right? That would be true north. It tells us to add 100 to our wind velocity. So we have our wind velocity is 0.1. We add 100 to that. So 100 plus 0.1. So our wind velocity is 101 knots here at 39,000 feet. And then for the direction, we subtract 50 from this number. So 76 minus 50 would give us 26. So the wind direction is from 260. Wind speed is 101 knots. And then the temperature would be minus 58. So tricky one there that you could get on the exam. If you see the first 2 numbers greater than 36, that's what you got to do. Yeah. So to do this, you subtract 50 from the first 2 digits and add 100 to the next 2 digits, the wind speed. Yeah, let's do another example. Let's see if there's another example here. I don't think there's another example on this one. Let's see if there's... Looking for another example. Let me go to the actual winds aloft. All right, so let's zoom in here. We got one right here. 800440. So first 2, right, are our wind direction. One moment here. All right, so first 2 are the wind direction. Okay, it's above 360, so that's our hint. It's above 36. It's 80. Okay, so that's our hint that it means the wind velocity is greater than 100 knots. It's 3 digits. So their next 2 is wind velocity, so 04, right? 04. So we add 100 to that. So we know our wind is 104 knots. Then for this first 2, we subtract 50 from that. So 80 minus 50 gives us 30. So now we go, okay, it's 30. So that's the wind is coming from 300. And then wind velocity, we add 100 to it, 104 knots. And then the temperature is minus 40. Does that make sense?
So we always subtract like 50 every time.
When it's like this and it's greater than 36. When it's like this, like 29, that's fine. Wind is from 290 at 57 because the wind velocity is not greater than 100. It's only when you see something greater than 36 in the first 2 numbers. So let's do another example. This one right here. What would this one be? 790946. But yes, when you do see that, you always subtract 50. You don't subtract like a different number. It's always 50. They removed the dash because above 24,000 feet, temperatures are probably never, ever positive. They're always cold, really cold. All right, so you guys got, so 790946. So you subtract 50 from 79, so you get 29. So that's from 290, and then you add 100 to 09, so 109, and then minus 46. Looks like you guys, 290, see if you guys all got that. Looks like you guys got that. Cole, you said 200 at 109, it'd be 290. Do you understand why?
Yeah, I just typed it wrong. I was typing too
okay.
fast.
Okay, cool. All right, good job. Okay, let's continue on. All right, so you can also see this in graphical form. I have pictures of this in the course, but if you don't like the winds a lot when you're actually using this, right, and you're not studying for the FA written, because you could have winds aloft questions there, you can see there's like a graphical heat map of all this information where you can choose your altitude, you can things like that. So when you're actually using this information, if you don't want to use the data table like this, you can do like a graph. It makes it a lot easier to use. So all right, next up, I talked about, we saw some wind symbols in your guys' homework, but we haven't got yet to explaining how to read them. So the first thing is the direction. Okay, so the direction is the flag part of it. So these are the flag parts, these things that come off the stick, right? Oh, let me get my pointer out again. So these parts that come off, that's like the flag, right? So this is the flag pole and this is the flag pole and flag. The flag end points to where the wind is coming from. Okay. So what I like to think of, this kind of looks like an arrow, like a bow and arrow, right? Where this would be the sharp end down here, the arrowhead. And it's like shooting with the wind. Imagine you're over here, you shot your arrow from where the wind is coming from, and the wind is blowing in the direction the arrow is going. That's how I always kind of thought of it. Or you can just think of it's pointing to where the wind is coming from. Okay. So this one up here, where is the wind coming from? Just kind of guesstimate. You could say, north, south, east, west, that type of thing, or you could say a number. Right. Yep. It's coming from the northeast. Okay. It's coming from up over here. All right. What about this second one? Where's that coming from? Northwest. Yep. And what about this last one? No, it's not the north. It's coming from the south. Remember these things that come off the flag parts, this side points in the direction the wind is coming from. The wind is going north, but it's coming from the south. Important to not get confused about that. All right, now it also tells us the velocity. That's what these flag things are. Each full flag line, like right here, what you see right here, is 10 knots. A half one is 5 knots, and then a triangle is 50 knots. And you add them all together. Okay. So this would be 1/2, which is 5 knots. And then this would be, so you got a half one, and then you got another half one that's red. So the red actually tells us the gust factor. So you add the gust factor. So let's quiz you guys. This first one, what do you guys think this first one is? We know it's from the northeast. How many knots? So we got people saying 75. 75. So we got the triangle, which is 50, plus 10, which is this full one. Now we're at 60, plus another 10, which is the next full one, which is 70, plus this half, which is 5, so we're at 75. All right, what about the second one? 5, 5, 5. Yep. So the one thing that's hard about these is when it's just one, it's kind of hard to know, is this a full one or is this a half one? So to me, it kind of looks like, based off the size of this one, it looks like a half one. So 5 knots, right? And it's from the northwest. So from the northwest at 5 knots is the wind. All right, now what about this one? This last one here with the red. All right, we got 5 gusting to 10, 5 gusting to 10, 10 knots gusting to 20. So this looks like a half of a bar to me. These both look like half of a bar, so they're both 5 knots. So we start with the, why is this not working? All right, sorry, my pointer's all over the place. All right, there we go. All right, this first, so we start with this, so it's 5 knots, and then you add, so this is red, it's another 5 knots, so it's 5 knots gusting to 10, right? If this was a full one, it'd be a gust factor of 10, which we add to that. So it'd be like 5 knots gusting to 15 if this was a full red one. Okay. All right. Any questions on that stuff before we get into I want to kind of do an intro on the airspace, like I said. Then you guys I'm gonna have you guys do homework on the airspace. And then we're gonna do a review on the airspace where I quiz you guys and we kind of try and get that rote memorization stuff down because there is a lot to know about airspace. So we just kind of got to hit it a few times for that repetition. But any questions before we bathroom break? Yeah, let's do it. Well, so let's be back at 6. It's 5:55. What do the sides of the flags mean? What do you mean the sides?
I guess just the angle of the notches on the side of the long one.
Like the angle it makes with the the pole?
They all look like they're on the left side.
Well, this one's like,
I'm not sure what you're saying.
so the long bar represents the direction of the wind. Does it make a difference
Like what
where the
side?
short bars point into?
No, 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 no. That's just these parts, they only tell us the velocity.
Okay.
Yeah. All right. Got about 1 more minute. Okay, let's get started again. All right. National Airspace System is a complex network of airspace, navigational facilities, airports, air traffic control, and rules that work together to ensure the safe and efficient movement of aircraft throughout the U.S. airspace. So think of it as a volume of air, just a three-dimensional space of air that is signified as either class Alpha, Bravo, Charlie, Delta, Echo, and each one comes with a certain set of rules. Okay, so the places where there's more traffic and larger aircraft, there's going to be a more stringent rules and things like that. So it's basically what it is. So you have controlled airspace. When we say controlled airspace, that could be Alpha, Bravo, Charlie, Delta, and even Echo. Okay, Echo is considered controlled, even though you don't have to communicate with ATC, it still is technically controlled, and because it has some rules. Okay, when you hear uncontrolled, that's class Gulf or class G. Okay, so the FAA written likes to have some questions where they say in uncontrolled airspace, or they like to consider, instead of saying class Gulf, they say uncontrolled. But if you see uncontrolled, just know it's class G. There's also some special use airspace, which you're going to get as homework. We're not going to cover those here. There's just kind of one factoid to remember about each of these. So I'll have you do that in the homework. But you have military operations areas, or MOAs, controlled firing areas, prohibited areas, restricted areas, alert areas, weather warning areas, or national security TFRs. They're mostly all related to military activities or disaster relief, like just this kind of different things like that. All right. Class Alpha or Class A airspace is not marked on your sectional charts. Class Alpha in the contiguous US extends from 18,000 feet MSL. So up here we got 18,000 feet MSL all the way up to 60,000 feet, or what they call FL 600, flight level 600 is 60. So this is all Class Alpha. And we are not allowed to fly in Class Alpha. You have to have an IFR rating to be able to fly in Class Alpha. So VFR private pilots, we have to stay below 18,000 feet. But most of the aircraft we fly anyways can't get up to that high. So that's okay. All right, next up, Class Bravo. Class Bravo airspace is marked by solid blue lines with the altitude for floor and ceiling denoted as a fraction in thousands of feet MSL on aeronautical charts. Okay, we'll show an example of what that looks like. But solid blue lines, those are Class Bravo. Minimum pilot qualification is a private pilot or student pilot certificate plus an endorsement from your flight instructor. So if you as a student pilot want to fly solo through a Class Bravo, you have to have a special endorsement to be able to do that. The endorsement says that your flight instructor has flown with you through Class Bravo, has done communications training with you, has done all the things associated with Class Bravo with you, and they'll give you an endorsement. Endorsement is good for a specific amount of time. That's the only way a student pilot can fly in Class Bravo. Generally, it's not recommended that student pilots do that, but some flight schools, they're literally inside of a Class Bravo, so you can't help it. Like if you're training out of somewhere, but if you're a private pilot, you can fly through Class Bravo. All right, so here's an example. So these solid blue lines are Class Bravos. And so you have these different kind of rings. This is kind of a, very symmetrically appealing to the eye, concentric rings. But as you can see here, you have 80 over SFC. I don't know if you guys can see that. That's why I blew it up here, but 80 over SFC, that's inside this blue area. That tells us that from the surface, the SFC means the surface, to 8,000 feet. So you add 2 zeros. Again, it's hundreds of feet MSL. Did I say? I said thousands of feet MSL here, so that was wrong. So I apologize for that. So it's hundreds of feet MSL. So you add 2 zeros to that. So surface to 8,000 feet. So that means in this area here, class Bravo is between the surface and 8,000 feet. Then here, this inside between these two circles, we have 80 over 19. That would mean from 1,900 feet to 8,000 feet. That's where that class Bravo is. Then as we kind of go out, you can see it kind of steps up, the floor kind of steps up. Then we have from 3,000 to 8,000. That's 80 over 30. And then over here we have 80 over 40. That's 4,000 to 8,000 feet. So what does that look like kind of three-dimensionally? Well, you kind of get these like cone type stepping stones, right? And that makes sense because if we have aircraft landing, we want during their approach to land, we want to kind of have them be in that airspace the whole time. So that's kind of why they do this, right? So the further away, you're going to have it a little bit up higher. And then as you get closer, it's going to go closer and closer to the ground until the airport's going to be right down here in the middle of it. That's kind of why they do these stepping stones. And then if you were to fly under here, right, as a student pilot, you wouldn't need an endorsement. You'd be under class Bravo, but you wouldn't be in class Bravo. But you'd want to be careful, especially if you're flying like under here, not to bust. You might hear bust class Bravo. That means you're not paying attention to your altitude. You're flying under a class Bravo and you're not supposed to be. And you forget to keep an eye on your altitude and you start climbing and you get into there. ATC is going to be like, what the hell are you doing? Get out of here. And yes, it is usually for bigger airports. High traffic, large aircraft airports is class Bravo. So we just show a little animation. All right. VFR weather minimums. That's the one thing we're going to talk about today. There's some other rules like speed limits and equipment that I want you guys to learn about in the homework. We're not going to cover that, but it's a couple more items of rote memorization for each of these. We're going to focus right now on the minimum weather requirements for VFR flight. So what that means is as a private pilot, we can fly VFR. We can't fly IFR. We would need an instrument rating to do that. But as a private pilot, we need to fly VFR. So if we're a private pilot flying in class Bravo airspace, these conditions have to be met in order to maintain VFR flight. So we have to have a visibility of at least 3 statute miles, and we have to maintain clear of clouds. If we can't do that because there's an overcast cloud layer, or if our visibility, because there's fog or something, is less than 3 statute miles, or we can't remain clear clouds, then we can't fly in class Bravo in VFR. So as private pilot, we can't do that. So clear of clouds, if you had like few clouds, you had a cloud here or there, and you could just fly around them, as long as the visibility is 3 statute miles, you're good to go. All right, so a mnemonic device. I want to kind of talk about some mnemonic devices that I like to use to remember this stuff. So I like to use 3 COC, which stands for 3 statute miles visibility and clear clouds. 3 COC, okay? COC means clear clouds. 3 152. So in this class Bravo example, we had 3 COC. We're going to have some examples, as you'll see, where you have to maintain 3 statute miles visibility, and then you have to be 1,000 feet above, 500 feet below, and 2,000 feet horizontal distance from clouds. Okay, so it kind of creates almost like a, not quite a cube, but a rectangular shape around the cloud, such that you have to maintain 1,000 feet above it, 500 feet below it, and 2,000 feet horizontal of it. They do this so that if there's an IFR pilot flying through that cloud, it keeps the VFR pilots, not right next to that cloud. It maintains some separation there. So that's kind of why they do it. But when it's 1,000 feet above, 500 feet below, 2,000 feet, I remember it, this little mnemonic as 3 152. It could also be 5 111 is another mnemonic. That means 5 statute miles visibility, 1,000 feet above the cloud, 1,000 feet below the cloud, and 1 statute mile horizontal. All right, so if you remember these 3 things, they can help you with remembering all these weather minimums. So write these down as a good memory aid to what they are. And this is in the course as well. All right, and then the second memory aid is to build this triangle. This probably helps the most students. There's other ways to do it for sure, but this triangle helps the most students. If you just remember to draw the triangle and then these inner triangles and then this bottom layer, you kind of get used to drawing that shape and just practice it over and over and over again. Then once you kind of remember the shape, then you can kind of remember adding in these altitude levels, and then you just fill in each of these spaces with what we're going to learn. So we're going to fill this out as we go. And at the end, you'll get a full filled out pyramid, and just practice drawing that from memory over and over again. That's how I remembered all these things for the exams. Okay, so we got class Bravo here. It's 3 statute miles visibility, clear of clouds, 3 COC class Bravo. Okay, and this covers all altitudes. That's kind of why it's down here separate. It doesn't have altitude consideration, so it's just down here separate from that. All right, class Charlie or class C. The shape and ceiling of each class Charlie are different for each airport, as they are specifically tailored to the airport they surround, the type of aircraft coming into them, and things like that. Usually class Charlie consists of a 5 nautical mile radius core that extends from the surface up to 4,000 feet AGL, as well as 10 nautical mile radius shelf that extends from no lower than 1,200 feet. This is kind of usually what they start with when they're planning class Charlie airspace, and then they'll tailor it to the specific airspace. But they usually start with this. Again, the altitudes are charted in MSO. They're marked by solid magenta. Class Bravo was solid blue. These are solid magenta lines. Minimum pilot qualification is going to be that student pilot qualification. So you can just be a student pilot and you can fly in class Charlie. You don't need that endorsement from your instructor. You would obviously need a solo endorsement from your instructor to fly solo, but that you wouldn't need a specific class airspace endorsement like you do for class Bravo. So class Bravo, to fly as a student pilot, you have to have your student pilot certificate, you have to have your solo endorsement from your instructor, and you have to have a class Bravo endorsement from your instructor. So 3 different things that you have to have for class Bravo. Class Charlie, you just need a student pilot certificate and your solo endorsement to fly solo in class Charlie. All right, so we mentioned these solid magenta lines. That tells us it's class Charlie. Same thing, floor and ceiling in hundreds of feet. So we have 40 over 15. That means in this section here, we have class Charlie from 1,500 to 4,000 feet. And then in this circle around the airport, it goes from the surface to 4,000 feet. So what is that? Actually, before we see what that looks like, I just want to show one other thing you might see. So you might see something with a T on it. So the circle T over 15, or over here it's T over 15. This can happen with other airspaces as well, but it's common to see them in class Charlie or Delta airspaces under a class Bravo. In this situation, the T tells you that the lower airspace continues up until the upper airspace begins, no matter what altitude that is. So if you look here, we have this magenta, and it's overlapping these blue class Bravo areas. So if you see this class Bravo area has 100 over 21. So class Bravo is from 2,100 feet to 10,000 feet in this area here. And there's also class Charlie in this area here as well. And in this area, the T tells us that it starts at 1,500, that's the 15, and it goes up until the class Bravo floor. So in this example, it would be from 1,500 to just below. Sorry, this is, gosh, I got another error here. Let's just say 2,099 feet, not 2,999 feet. Sorry about that. Oh, wait, no. Sorry. It is right. It's this arrow that's talking to this location. Okay. So 1,500 to 2,099 feet. And again, why the 2,099? Basically 2,099.99999. Basically all the way up until the class Bravo starts, which is at 2,100 feet. That's what the T stands for. And then in this area, the where is that class Bravo? I think, yeah, right here. The class Bravo in this area goes up to, it starts at 3,000 feet. So that's why this class Charlie in this area, where this class Bravo starts at 3,000, it would be from 1,500 to just below 3,000 in this area. Again, because it's different than this area, because class Bravo starts at 2,100 feet in this area. But in this area, it starts at 3,000 feet. Any questions on that? Okay. And this is kind of a 3D view of what it looks like. Again, you got that kind of step shelf. Obviously, we'd have most of our traffic, kind of stepping down as it either climbs out or comes into land here. Now the VFR weather minimums, it's going to be for class Charlie, it's 3 statute miles, and then it's that 152. So it's 1,000 feet above. I kind of did them in different order. Sorry about that. 1,000 feet above, 500 feet below, and 2,000 feet horizontal. So that's the 152. And we'll put the class Charlie here in the center of our triangle. All right, next up is class Delta, an airport which has an operating control tower but does not provide weather services as in class radar services as in class Bravo or Charlie, is surrounded by a class Delta airspace. So again, it's like less, it's controlled, but it's a little bit less controlled. You still have to talk to ATC, but they're not going to provide you all these fancy dancy services. But you got to talk to them. You got to get permission to go in them, all that good stuff. So again, it's like a municipal type airport where most general aviation training centers are. You can have them at class Charlie and class Bravo, but usually those airports are for the bigger aircraft. If the tower does not have continuous operation, it's not 24/7, then the airspace becomes a class Echo when the tower closes for the day. Okay, so this is a common test question here. So it just reverts to the lower airspace when a class Delta closes for the day. So there will be some class Deltas that are only operate from like 6 a.m. to 6 p.m. When the tower closes, the ATC goes home for the day. It just turns into a class Echo. Class D airspaces are marked by dashed blue lines. So we had solid blue, class Bravo, solid magenta, class Charlie. Class D are dashed blue on our aeronautical charts. You also sometimes see a minus sign in front of the ceiling marker. This indicates that the number is not inclusive, and I'll show you an example. Minimum pilot qualification is, again, a student pilot. So just like class Charlie, you got to have a student pilot certificate and a solo endorsement to fly solo in class Delta. You don't have to have a specific airspace endorsement. All right, so here's an example. We got the dash blue circle. Now you're not going to see a floor. You know how with like this class Bravo here, we have a 100/48. It's got the floor on the bottom and got the ceiling at the top. You're only going to see a ceiling for class Delta, and it's going to be in like this bracketed square. So it says 38. Again, that's in hundreds of feet. So 3,800 feet is the ceiling. But as I mentioned, and the floor is always going to be the surface for class Delta. So it starts from the surface up to whatever number this is in hundreds of feet. But this dash sign tells us that it's not inclusive. So what that means is that really, once you get to 3,800 feet, you're technically not in this class Bravo or class Delta anymore. And likely you're in another airspace, like, right? Not class Bravo here because it starts at 48, but as soon as you hit that 38,000 feet, I think they had to do this for legal purposes. They had to be this specific. But basically it goes up to 3,799.99999 does this class Delta. It's not inclusive of that last foot. That's what that minus sign means. So that's the 3D view of what that is. Yeah, so between 30, so at 3,800 feet up until in this area where this arrow is pointed to, up until 4,799 feet, you'd be in class Echo. And then once you get to 4,800 feet, you'd be in the class Bravo in this area here. Over here, outside of this class Bravo, it'd be from the surface to 3,799 is class Delta. And then everything above that, I mean, we can't see what else is going on, but it's likely class Echo. That's what it would look like there. And if we're at the location, so this is kind of what your question was alluding to. If we're at the question of this red arrow, the airspace in 3D would look something like this to us. And this is kind of what you're talking about. We'd have class D to 3799. Then we'd have this little gap of class Echo airspace before the class Bravo kind of starts up here and does this sort of L shape. So if we were right here, right, between 3799 and 4799, we'd be in class Echo where this arrow is pointed to. And then class Bravo would start at 4,800 and go up to 10,000 because of this 100 over 48. And then above that, it would go back to class Echo until 18,000 feet. So above this would go back to class E, and then class E ends at 18,000 feet where class Alpha begins. All right, so the VFR weather minimums, we have 3 statute miles, and again, we have that 152. And again, sorry, I put them out of order, but 1,000 feet above, 500 feet below, 2,000 feet horizontal. Ivan, what are you saying? All the way to Alpha outside where Ramona is?
The question is about if we look outside Bravo,
So over here.
correct.
Okay.
So above 3,800 feet, I mean 3,799 all the way to 18K would be Echo.
Yes. And then Alpha starts at 18,000.
Okay, thank you.
Yep. All right, so we got 3,152 for class Delta. So we're going to also put class Delta in here. This middle triangle is perfect for our 3,152s. Okay. So we have class Bravo, 3 COC. We have class Charlie and Delta, 3,152. All right, next up we have class Echo. It's marked by shaded magenta lines, but also dashed magenta lines, which we'll show here in a second. The shaded magenta is going to go on one side of the big thick line is going to be more like a solid magenta. And then on the other side, it kind of fades to where it's almost like very transparent on the other side. Now on the solid side of the line, everything to the solid side, class Echo starts at 1,200 feet AGL and then goes up to either another airspace or 18,000 feet. Everything on the fainter side or the transparent side to the transparent side of the line, and we'll show an example, starts at 7,000 feet AGL. And then if there's a dash magenta line, then inside the dash magenta area, the class Echo starts at the surface. So let's see an example here. Actually, first, minimum pilot qualification, again, student pilot certificate. You don't need an endorsement to fly in class Echo. You would need a solo endorsement to fly solo, but that's it. All right, so here's that shaded magenta line I was talking about. You see how here on the outside of it, this is like the more solid side of the magenta line, and then it kind of fades on the inside. So that's what I'm talking about. So everything on this outside of this circle, on the darker side of the line, class Echo starts at 1,200 feet AGL. Everything inside starts at 700 feet AGL. And then if you have this dashed magenta, which we show here, it starts at the surface. And then if there's no airspaces above it, it goes up to 18,000 feet in each case. So again, that's going to look like this. Again, you have that kind of stepping stone as you get close to this little regional airport. Okay. And again, because they want controlled airspace as people approach or climb out of this airspace. And again, class Echo, there's no rules on talking to ATC. There's no control tower, but there are some rules. There's some VFR weather minimums and some other rules that you need. And so that's why they do it. It's not completely uncontrolled. Do whatever you want. There are some rules, and that's why. What is the 0-1200 on the bigger ring?
If it starts at 1,200, so what's the airspace below 1,200?
Oh, that would be class Gulf, class G. Okay, so anything under class Echo, unless it's surrounded by another marking for airspace. So out here, you would have class Gulf or uncontrolled airspace from the surface to 1,200 feet AGL. In here, class G would be 0 from the surface to 699 feet AGL, right? So underneath here, if I'm flying around in here, this would be uncontrolled airspace. Good question. All right, so for the VFR weather minimums, it gets a little trickier with Class Echo and then even more trickier in Class Gulf. But Class Echo, it divides between below 10,000 feet and above 10,000 feet. For below 10,000 feet, it's easy. It's a 3,152. 3 statute miles, 500 feet below, 1,000 feet above, 2,000 feet horizontal. Above, we have the 5,111. So it's 5 statute miles, 1,000 feet below, 1,000 feet above, and 1 statute mile horizontal distance from clouds. Okay, so we put E here below 10,000 feet. So it's included in this 3,152 when it's below 10,000. But above 10,000, it gets its own little block here of 5,111. Okay. All right, the last one, Class Gulf, Class G. It's uncontrolled or governed free. It's a void from air traffic control jurisdictions. So that's why you call it uncontrolled airspace. It exists wherever Class Alpha, Bravo, Charlie, Delta, or Echo does not. That's where it exists. It's not marked. It's usually not marked on charts, but I'll show you an example where sometimes it is marked on charts. So practically, it starts at the surface and extends up until it hits Class Echo airspace or any other airspace at either 700 feet or 1,200 feet AGL. But usually, it's going to be hitting Class Echo airspace. Right. So again, the example that we showed, actually, this is a different example. There's no, so before, all right, so before here we had this ring. Oh, actually, I didn't show this. So this ring of dash magenta, right? That tells us it goes to the surface. And if it didn't have that, right, you would have between the surface and 700 feet, because there's no magenta ring that tells us, or dash magenta ring that tells us it goes to the surface. It never goes to the surface. So inside this shaded one, it just starts at 700 feet. So inside here, if you were below, so if you're at this airport, anywhere from the surface to 6,999 feet, you're at Class Gulf. Once you get up to 700, then you would go to Class Echo. So if we go back to Class Gulf, right here, underneath here, again, would be, so you can fly under here, govern free, uncontrolled airspace if you float. I mean, I wouldn't advise flying that low, but you could. So there kind of fills in the gaps, right? Wherever Class Echo isn't, is Class Gulf. All right, again, there's usually no specific markings, right? We don't see any markings here. We just see Class Echo. So wherever Class Gulf is not, then that's what we have. So usually just under Class Echo. However, there's another one that's not the standard under Class Echo. And these areas, unless otherwise marked, Class G extends from the surface to 14,499 feet with Class Echo starting above it at 14,500 feet. And in this scenario, it's going to be marked with a thick blue shaded line or by a thick blue treaded line. So let's see some examples. So here, if you see just like the magenta line, but it's blue, that tells us that Class G is from the surface to 14,500 feet. And then Class E would be above it. It's rare to see this, but there are examples. And then out here, right, we have Class Echo starting at 1,200 feet because there's somewhere out here, there's shaded magenta lines, and we're outside of that. So that means Class Echo starts at 1,200 feet. So this would be the normal Class Gulf below it. But inside this blue, that tells us Class Gulf is up to 14,000 feet. And then you also might have these tread lines. Okay. So you kind of have a mix of these shaded blue and then these tread lines. So the shaded blue tells us it's that 14,500 feet. Okay. And so the Class C floor is at 14,000 feet, 500 feet with Class Gulf below it inside the shaded blue. But inside these treaded areas, that's signifying that it's not the standard 14,500 feet and it's up to 4,000 feet. So we have a Class E floor at 14,000 feet here, Class E floor at 9,000 feet in here. And then in here would just be our normal. And yeah, usually these would be like near military. You can see there's like a line for like MOAs or like this is a wildlife area, these like dotted lines. So they would want to keep I know there's different rules and things. There's a restricted area here. There's obviously a lot going on here. So they've just got kind of designed like this corridor, and kind of, again, made these kind of shelves as you go out of uncontrolled airspace. All right, so class Gulf is tricky with our VFR weather minimums. At or below 1,200 feet AGL in the daytime, it's visibility 1 statute mile clear clouds. So it's 1 COC. Okay, so it's kind of a new mnemonic, 1 COC. At or below 1,200 feet AGL in night, it's 3 152. So it's our 3 152. And that is below 1,200 feet AGL at nighttime. At or below 1,200 feet AGL at night and within a half nautical mile or nautical mile of airport in the traffic pattern. So if you're in the traffic pattern at night below 1,200 feet AGL, then it goes back to 1 statute mile clear clouds, same as the day. So basically they say, okay, well, if you're staying within the pattern at night, then it can be the same as the daytime. All right, so if we fit that in here, we have class G at night over here in this triangle, class G in the day over here. And then below 1,200 feet, we have 1 COC in the day. Below 1,200 feet, we have 3 152 at night. But if you're within a half nautical mile to the airport, it's 1 COC as well. We're just kind of filling in these different gaps. And then finally, above 1,200 feet, but below 10,000 feet in the day, we have 1 statute miles, and then we have 152. Above 1,200 feet, but below 10,000 feet MSL at night, we have 3 152. And then at or above 10,000 feet day or night, we have 5 111. 5 statute miles, 1,000 feet above, 1,000 feet below, 1 statute miles. So I did not include the final one here. Let me grab that for us. So we can see what that final triangle looks like. Sorry about that. That's pretty much the end of that. And so we add here above 10,000 feet, we have the 5 111 for class Gulf. Below 10,000 feet, but above 1,200 feet at night, it's 3 152. Below 10,000 feet, but above 1,200 feet in the day, it's 1 152. So a combination of these 3 152, 1 152, 1 COC, 3 COC, and this triangle really helped me. It's like remembering 10 things instead of remembering 30 things, right? And then the visual of the triangle, the shape of the triangle in my head helped a lot because I could see it in my head. And when I sat down to write the test, I just drew this out so I didn't have to think about it. I drew it out, I memorized how to draw it, and yeah. And we'll cover this again. We're going to quiz you guys again on this stuff. We're going to do another airspace review. I want you guys to go through the lessons, see it again, do the quiz, and then we're going to do a whole kind of review on it as well, because it is a lot. It takes repetition. All right. Any questions?
I have a question on the Blue Echo airspace. Can you go back to that photo really quick, please?
Yeah. 1 sec. Okay.
Sorry, keep going. It's like a chart image, and it shows like the blue vignette and the zipper. Or you called it a tread line or something.
Yeah. This guy. Right?
Okay, so yes, thank you. So it looks like on the left side of the screen, class Echo floor it's on the darker shaded, right, of the vignette, and the floor starts at 14.5.
Of this magenta?
Sorry, no, it's the blue one, the top left. Yeah, that one.
Okay, so
that looks like the darker side. Yeah, right?
Yeah, so don't worry about when it comes to the blue shaded, which is for class Gulf, it's going to completely encompass an area. So it's going to like make an outline. And so it doesn't matter. Like you're just concerned with what's inside of it, not outside. Outside of it, it goes back to class Gulf is just under class Echo. Does that make sense? So like here we can't see because I cropped this out, but this blue, this it would make some sort of enclosed shape. And inside that enclosed shape is all we care about. And that tells us the blue kind of vignette. Inside the blue vignette tells us that class Gulf goes to 14,500 feet and class Echo is above it.
Okay, and then go to the other photo that you just had for a second, please.
Mhm.
This one. Okay, so there's, yeah, that one. So it has class Golf is less than 1,200. How do we know that?
Yeah, so because if you were to zoom out of this, we would see, let me see here. You would basically see, trying to get a good visual, but we would see the magenta vignettes somewhere, right? And you just know that everywhere else in the US is outside of a magenta vignette, is on the dark side of a magenta vignette. See this magenta vignette that tells us class E is from 1,200 to 1,800. So like, let me pull up Sky Vector real quick so I can show you, so we can get a wider view of what we're talking about. All right. Let's go to somewhere over here. All right. Do you see all these class Echo vignettes? Right. So all out here, can you see my little mouse? Let me see if I can.
Yes.
Okay. Yeah. So yeah. So all out here, we're outside of these vignettes. We're technically on the dark side of the vignettes in all these places. That means class Echo starts at 1,200 feet. Unless we see one of these blue vignettes that tells us otherwise. These guys right here. Sorry for these lines, but does that make sense?
Yeah, I think so.
So in this one, I know that we are basically in one of these pink areas, right? When we're outside of this blue one, where class Echo is going to start at 1,200 feet. Basically, class Echo starts at 1,200 feet everywhere unless we're inside of a magenta vignette or we are inside a blue vignette.
Okay, I think it's making.
Yeah. Good question. All right. Any other questions? While you guys are here, who just another friendly question of who's caught up on the homework. Yes, yes, yes. Couple lessons behind. Ha ha ah. So lagging for the first time almost. Nah. Finally. Late this time, not even close. Okay, that's all right. All right, so we're getting tougher, I see, for people to stay caught up. Now, if this trend continues, I'm not even gonna say it because I don't want you guys to think you have more time, but we'll as a group, we'll kind of just keep an eye on this. And that's fine, Kay. Like I'm glad you're doing that before you're moving on. Like really. Again, this is my first time doing this. I'm kind of gauging you guys, using you guys as to know how long this will take. I'm not feeling the part-time and part-time pilot right now. Yeah. There's no such thing as part-time pilot. That's the like when I spent too much time thinking of a name for my business, and I got on it because it was good keywords. Bait and switch. Yeah, maybe the VIP should be called full-time pilot. Sell the vision. You guys are funny. Cool. So let's pull up what the homework is. Where is that? Oh God. Where are you? Oh my goodness. There we go. All right. So we got all right, so I want you guys to go through those airspace lessons just again for the repetition. And then you got METARs, TAFs, PIREPs, winds, alofts, class echo. I think that's pretty doable. Couple days, so and then this one, right? I wanted to we're gonna get into aerodynamics next, and I wanted you guys to be able to kind of focus on that. So there's not a ton of homework. So I think you guys will have a chance to catch up, and we'll kind of get another barometer check on Friday. Before we kind of we're gonna do an airspace review on Friday. Which I should add to here on the topics covered, but obviously we got a big chunk. So we'll do another barometer check on Wednesday and then Friday to see. And honestly, if the trend continues, we might just do a catch-up day for everybody, or we all go through maybe just another Q&A day and give you guys more time to catch up. Please, you're saying. We got to make sure everybody's okay, because I did sell we're gonna get this done in 5 to 6 weeks. So we got to make sure everyone's okay with that. Minecraft video. What's the Minecraft video?
Look what Nick wrote 2 messages above mine.
But I found Minecraft video that shows airspace well. Oh, nice.
Yeah.
That's funny.
I'll
Yeah,
post.
yeah, share it. Nice, Nina. Okay. So yeah, let's do that. We'll do Wednesday as planned, and then this Friday we'll kind of do another barometer check with everybody. But try and get caught up if you can. And then even if people are caught up, but we're still everybody kind of wants just like a review day. Be a good time to do it. We're about halfway, so it could be a good time to do that. For shizzle. All right, guys. Well, my Mariners are playing Game 7 to go to the World Series right now, so I'm gonna go hopefully watch them win. But if you have any questions, reach out. I'm feeling kind of lonely on that phone line, so I guess no one wants to talk to me. No, I'm kidding. Go Mariners. Yes, there. All right, cool guys. And sorry about the delay in getting Fridays up. I had created it and everything. I just spaced on getting it up. So cool beans. All right, everybody.